All right. So in this module, I want to explain the difference between thermoset polymers and thermoplastics. So we can also break down the polymers, classes of polymers, into the following categories. So thermoplastics. So these are polymers that soften when you heat them and then harden when you cool them. And this is a reversible process. And therefore, these are the polymers that are most likely to be recycled because we can basically form them into a shape when they're softened at high temperatures, and then they harden when they're cooled. And if we recycle them, we can basically heat them back up to form them into whatever shape that we want. Thermosets are ones that are less likely and are usually not able to be recycled because these are the networked and heavily cross-linked polymers. And so once they're set, once those covalent bonds are set, they will not soften when heated. So basically, what happens when we heat them? So they're set, and then they would obviously, if they cool, they cool. But if we try to reheat them, they would just eventually decompose and kind of off gas and give off toxic fumes. We can also divide into a couple other categories as well. Synthetic fibers. So these are polymers that are synthesized into fiber shapes. So it doesn't really tell us much about whether it's thermoplastic or thermoset. But these are things like rayon, acrylics, nylons, and polyesters, which you might be familiar with in clothing. So fibers. And then there's also synthetic rubbers. These are typically known as elastomers because they have very elastic properties. So this could be something like polybutadiene, which is in tire rubber, and polysiloxane, which is silicone. Different than silicon. So those are some of the classes of materials that we can have. And we really want to, for this one at least, we want to kind of consider thermoplastics and thermosets. And the big difference here is that thermoplastics can be reversibly heated and cooled to soften or harden the material, and thermosets are set once they are synthesized. So with the discussion of the classes we just talked about, and the four molecular structures that we discussed in the previous module, linear, branched, cross-linked, and networked, what I want you to do is go basically with those four molecular structures and tell me which one you think will be can be recycled easily and which will not. So kind of discuss for each of those four structures. So do that on the quiz and then come back and we will discuss. All right, so let's take a look. So let's compare the thermosets and thermoplastics. So the main thing here is that thermoplastics, like I mentioned, soften when they're heated, harden when they're cooled, and this is reversible. So these are the ones, thermoplastics are the ones that are most likely to be recycled. So what's happening here is that when we heat and cool, what's happening is we're affecting the secondary bonds. So we're heating it up and we're allowing the chains and the secondary bonds within them to diminish at the high temperature, and we allow motion between chains. And then when it cools, we stop those from being able to move. And thermosets, or thermosetting polymers, are networked ones. So once it's hardened, when it's heated, those covalent crosslinks or networks are formed and they're irreversible. So if we heat it back up, again, the most we can do is destroy the material and decompose it. We can't go back to the prior condition. However, these tend to be harder and stronger than thermoplastics and have better dimensional stability. So these are kind of the more rigid, but again, these are not going to be recycled. So if we're looking at the two, linear and branched tend to fit in the thermoplastics, and then networked and cross-linked tend to fit in this thermo setting. And again, that kind of dictates whether something's recyclable or can be recycled or not.